Looks like we're starting off with both of the equations being in standard form, which is nice. The 4 and the 6 are smaller numbers than the 6 and the 9, so I'm going to go ahead and cancel. I'm going to figure out the least common multiple of 4 and 6. That is, what, 12? If you wanted to go with if you wanted to make these into 24s, that's 4 times 6. That does work, but you're going to end up with larger numbers than are absolutely necessary. I tend to like going with the least common multiple because it's going to end up with smaller numbers, and smaller numbers are just easier to deal with. So that's why I always go with the least common multiple. But technically, you could go with any common multiple of the two numbers. All right, so I can convert both of these into 12s, so I'm going to multiply the first equation by 3. I'll make that into a positive 12, which means I'll make this one into a negative 12 by multiplying the second equation by negative 2. When I do that, I get, let's say I'm multiplying my first equation by 3. So 12x minus 18y equals negative 15. The second equation, I'll multiply through by negative 2. I get negative 12x plus 18y equals negative 4. When I add these together, the 12x and the negative 12x cancel as expected. But the 18y and the negative 18y cancel also. When I do that, I get a 0 on the left-hand side of the equation. Everything canceled, so I have to write something there. And technically, there's a 0 over there, because this was 0x plus 0y. Ultimately, that's 0. So I get the equation 0 equals negative 19. Well, 0 equals negative 19. There's no variables in this equation, and it's a false statement. This is a contradiction, which means there are no solutions. There's no solutions to this equation. But just like with the substitution method, if we end up with no solutions to this equation, that means there's no solutions to this system. It means the two lines are parallel. Lines are parallel. Because that's the situation, that was of the 3 scenarios, that's the only case we had where we had no solutions. I could verify that, I suppose, if I wanted. You could go through here and check to make sure that they have the same slope but a different y-intercept. I'm not going to bother, though. If you want to do that, feel free.